Okay, so today we've got one of the greatest stories in all of science. Seriously, it's all about Isaac Newton, how he came up with the idea of universal gravity, couldn't prove it, and then just shelved it for almost 20 years. But then, a single conversation brought it all back, leading to a breakthrough that literally changed everything. Let's dive in. All right, let's set the scene. It's 1666. A young Isaac Newton, he's only 23, is sitting around and sees an apple fall from a tree. You know, something we've all seen a million times. But Newton, he looks up, sees the moon hanging there in the daytime sky, and asks a question nobody else had thought to ask in quite that way. Hey, why doesn't the moon fall down too? And that one question, that was the spark. It kicked off this incredible scientific journey. He started thinking, what if the force pulling that apple down is the exact same force that's holding the moon up there, tugging on it just enough to keep it circling the Earth? You really have to appreciate how just audacious this idea was for its time. I mean, think about it. Newton was basically saying that the rules down here on Earth were the same as the rules up there in the heavens. He was proposing this one single universal force of gravity that reached all the way out into space, getting weaker the further you go, but still calling the shots for planets and moons. So, being Newton, what does he do? He gets to work on the math. He starts calculating what it would take for the moon's speed to balance out the Earth's gravitational pull. And the answer he got? Well, it was close. Really close. Pretty nearly, as he put it. But here's the thing about a mind like Newton's. Pretty nearly is the same as wrong. It wasn't perfect, so what did he do with this world-changing theory? He decided it was flawed and just tucked it away for 18 years. And this, for me, is where the story gets really fascinating. I mean, what does a genius do for almost 2 decades after giving up on what would become his greatest discovery? Well, as it turns out, he just goes off and completely revolutionizes other areas of science instead. So you can see on this timeline, there's this huge 18-year hole in the gravity story. But it was anything but empty. While that big gravity idea was just sitting on a shelf somewhere, Newton was about to completely change our understanding of light. And, funny enough, it all started with a mistake. Yeah, so with gravity on the back burner, Newton poured all of his incredible focus into optics. He got totally obsessed with this one nagging problem that every astronomer at the time was struggling with. The problem was called chromatic aberration. You know those fuzzy colored fringes you'd see around things when you looked through an early telescope? That's it. And Newton, he came up with a theory about light, which turns out was actually wrong, but it completely convinced him that you could never get rid of that color blurring as long as you were using lenses. And this is just a perfect example of how even Newton's mistakes led to amazing things. Chasing this problem, he does his famous experiments with prisms and discovers that white light isn't one thing. It's actually the whole rainbow of colors all mixed together. And because he thought lenses were a dead end, he just invents a whole new kind of telescope, the reflecting telescope. Instead of lenses, it uses mirrors. And guess what? The fundamental design he came up with is still what we use in some of our most powerful telescopes today, all from a mistake. But believe it or not, that's not all he was doing in his downtime. During this same 18-year stretch, Newton was also, kind of in secret, forging a brand new mathematical tool, a tool so powerful it would basically become the language of physics. He called his invention fluxions. We know it today as calculus, and it gave him a way to deal with things that are constantly changing, like motion and speed and curves. The crazy part is, he had no idea at the time, but he was literally building the key that would unlock that huge gravity problem he'd given up on all those years ago. Okay, so fast forward to 1684. 18 years have passed. Newton's got calculus in his back pocket, he's revolutionized optics, but that big idea about gravity? Still collecting dust on a shelf. And then, everything changes. He gets a visitor. And this visit is all because of a nasty rivalry. So, to really get what happens next, you need to know about the bad blood between Newton and this other guy, Robert Hooke. Now, Hooke was no slouch. He was a good scientist. But he had this, let's call it a grasshopper mind. He'd jump from idea to idea, never really nailing anything down. And his most annoying habit was that whenever someone else solved a big problem, Hooke would pop up and say, "Oh yeah, I thought of that first." So Hooke is going around London boasting to everyone that he's cracked the code on how planets move. Newton's buddy, the famous astronomer Edmund Halley, Yeah, the comic guy. He's hearing all this and he is just not buying it. He's totally fed up. So he makes the trip out to Cambridge to see Newton, armed with a very, very specific question. And here it is. This is the moment. The question that changes science forever. Halley asks Newton, okay, let's say there's a force pulling the planets towards the sun, and that force gets weaker by the square of the distance. What shape would the planet's orbit be? And without even hesitating, Newton just says, an ellipse. Halley is just floored, blown away. How could he possibly know that just off the top of his head? And Newton's reply is legendary. He just casually says, why, I have calculated it. Turns out he'd done the math years before and then, just lost the paperwork. You can just imagine Halley completely freaking out with excitement, begging Newton to find the proof. So Newton agrees to go back and redo all those calculations from 18 years ago. But this time was different. This time, he had everything he needed to get it right. So, what was the difference maker? Well, two huge things. First, he now had his secret weapon, calculus. It was the tool he needed to prove something that had bugged him before, that you can treat a whole planet's gravity as if it's all coming from a single point right at its center. And second, the data was just better. In those 18 years, other scientists had gotten much more accurate measurements for the size of the Earth and the distance to the moon. So with his new math and the new numbers, he crunched it all again. And this time, it wasn't pretty nearly. It was perfect, a perfect match. And the result of all that work was this masterpiece, the Principia Mathematica. And here's a great little side note. The official scientific body, the Royal Society, was too broke to publish it. So Edmund Halley, the guy who asked the question in the first place, he paid for the whole printing himself. It's safe to say this is probably the single most important science book ever written, period. And what was inside? I mean, it was basically the instruction manual for the universe. Newton lays out his law of universal gravitation, his famous 3 laws of motion. He finally explains why the planets move in the way that Kepler had observed. He explains the tides. He built the entire foundation of what we call classical mechanics. It was the whole shebang. But the Principia's impact was so much bigger than just a bunch of equations. Its real power, its true legacy, was psychological. What Newton did was show humanity that the universe wasn't some chaotic, magical, unknowable mystery. No, he proved that the exact same simple law that governs a falling apple also governs the dance of the planets. For the very first time, it felt like the heavens were finally understandable, that they were within our grasp. You have to remember, before Newton, even the best scientists kind of felt like they were living in the shadow of the ancient Greeks, like Aristotle. After Newton, that was over. He gave science this incredible shot of self-confidence, this core belief that, hey, the universe makes sense, it follows rules, and we have the power to figure those rules out. The poet Alexander Pope probably said it best, nature and nature's laws lay hid in night. God said, let Newton be, and all was light. And that just perfectly captures how people felt at the time. Like after centuries of fumbling in the dark, one person came along and just flipped on the lights. It really makes you think, doesn't it? What other huge 18-year problems are just sitting out there, waiting for someone to invent the right tool or just ask the right question?